For us to understand this topic easily, we have to break down the meaning of these two terms, measurement and unity. What is a measurement and what is a unity? If we are able to define these two terms, then this topic is gonna be very easy for us. So, in your own definition, how can you define measurement? So, measurement is simply the process of quantifying the dimensions of the given object. For example, let's say we have been given a rectangle like this one. So, for us to determine the dimensions of this shape that we have been given here, we have to measure. So, that process of identifying the dimensions of this object is what we call measurement. If we take note of the distance, let's say from this side up to there, this distance in between here is the measurement. So that process of identifying the dimensions of the given object is what we call a measurement. So in short, a measurement is simply the process of quantifying the dimensions of an object or of the given object. So here is the simple definition in case you might want to write down. So measurement is simply the process of quantifying the dimensions of an object. Now that we have understood what a measurement is, let's also understand the meaning of the term unity. What do they mean by this term? We hear this term almost every day. Now, what is a unit? How can you define a unity? So, a unity is simply a standardized measure used to quantify and compare different amounts or attitudes, or rather magnitudes. Okay, so a unity is a standardized measure used to quantify and compare different amounts or magnitudes. So let's view the definition so that you may write it down. So here is the definition of the unity. So a unity is simply a standardized measure used to quantify and compare different amounts or magnitudes. So there are a lot of examples that we can use of different physical quantities. For example, the length. The length has the units. Of course, we know the units for length are what? Meters, feet, inches, centimeters, millimeters. Those are some of the examples of the units of the physical quantity, the length. Even mass has different units. We have the kilogram, the gram, the pound, etc. There can be a lot of them, but let's just mention a few. Time has also its own units. So the units for time we know are familiar. We are familiar with them. Of course, we know they are seconds, minutes, hours, days, weeks, months, years, and more that we can talk about. The other physical quantities, of course, we can talk about are volume, temperature, currency, and others. For volume, we know that volume has the units which of course are liters, gallons, cubic centimeters, cubic meters, etc. When it comes to temperature, we know we have the Celsius, Kelvin, Fahrenheit, etc. and a lot that we can talk about. Now, my question is currency a physical quantity? And if it's a physical quantity, what are its units? So, the units for currency, of course, are dollars, euros, pounds, yen, kwacha, and some others that we can talk about. So, even currency is a physical quantity with its units, of course, dollar, euros, pounds, yen, kwacha, as I have already talked about. Okay, so we have different examples that we can define or we can determine for us to understand a unity. So what's important is understanding the definition that we have in the board here. So if having understood this, let's look at the physical quantities and its examples. So here is a summary of the physical quantities and the examples of the same units. So this side represents the units and this side represents the physical quantities that we have. So make sure that you take note of these. So we have main types of units. There are main types of units that we can talk about. However, in this video we are just going to talk about two main types of units. The first one is the base unity. What is a base unity? A base unity is simply a fundamental independent of units that form the basis of a measurement system. For example, we have meters, we have kilograms, we have kelvins, we have mole, we have candela, we have ampere, we have more and more that we can talk about. So the base units, of course, are the units which cannot be derived from other units. So let's look at some of the examples of these same units. So some of the examples of these base units, as talked about earlier, are meters, and we know that meters are the units for length. Kilograms we know are the units for mass. Ampere we know are the units for the electric current. Kelvin we know are the units for temperature, and then mole we know is the unit for the amount of substance, and also the candela is the unit for the luminous intensity or light. So these are the examples of base units. There are mainly 7 many base units. These 7 cannot be divided, or rather cannot be derived from other units. So all other units are derived based on these 7 base units. So that's very important for us to understand. Now, the opposite of the base unity is what? Is the derived unity. What are derived unities? So just as the term itself implies, derived units are simply defined in terms of the base units, meaning they are the units that are derived from the base unity. So upon combining the base units, what results is the what? Is the derived unity. So that's very, very important for us to understand. Now, what are some of the examples of the derived units? So we can have, for example, force. Force is the physical quantity, and its unity is a derived unity, which of course is the Newton. Even what for power, Haze for frequency, speed. We also have other different examples of derived units that we can mention, but let's only mention a few because we can't go up to the end. There are a lot of them. So if we have combined units of more than one unit, that one is a derived unity, or rather falls in the category of the derived unity. So derived units are constructed by combining base units in various ways. In order to add or subtract the quantities, they should have the same units. For example, we cannot add, let's say for example, we cannot add 8 kilogram with 4 gram. Why? Because these do not have the same units. Units are different. So these cannot be added. So one of the rules that we need to understand when it comes to adding the units is that the units have to be the same. They have to be of the same match. So in this case, if we have 8 kilogram, it means that we should also have 4 kilogram for us to have the total of what? 12 kilograms. So the units of course have to be the same. It doesn't matter what kind of them. For example, we may have 2 centimeters cubic. If we add this to 3 centimeters cubic, what are we going to have? Of course, we are going to have 5 centimeters cubic. We know that. So the units in short have to be the same for us to add or subtract them. So this is a very important point for us to understand. Now, the other thing that we need to understand is that all other physical quantities can be constructed from 3 main quantities. Now, what are the 3 main quantities that other physical quantities can be constructed from? Well, the first one is the length, the second one is the mass, and the third one is the time. These three are the main physical quantities, and others are derived based from these three. So we need to understand and know much what these things are. So having discussed all this, let's now discuss the powers of 10 used with metric units. How do we call the terms, or rather the powers of 10? For example, if we have 10 power 3, what term is given to this one? So we need to understand this. If we have 10 power negative 3, what term is used for this one? So it's very, very important for us to know the terms, because sometimes they can't just say 10 power 3 or 10 power negative 3, but there is just simply a term that they can use for them to refer to these numbers. So it's very, very important for us to understand. So if we have a term which has power of 3, this term is called kilo. So whenever you see the word kilo, what should come into the mind is that that unit has 10 power 3. For example, if we have, let's say, 10 power 3 centimeters, let's say we have kilogram. So since there is the word kilo here, it means that whatever unit is here has 10 power 3 times of this figure here. So in this case, then it means that we have 1 kilogram representing 10 power 3 of the grams. If we have 2 kilometers, we know that we will have what? Okay, we will have 2 multiplied by 10 power 3 meters. Why are we having this 10 power 3? Because of the kilo here. So kilo itself means 10 power 3. Okay, so there are a lot that we can talk about. What if we have 10 power negative 3? What is this called? So 10 power negative 3 is called milli. Okay, milli. So milli, whenever you see this term, of course, you will know that you have 10 power negative 3. So other terms will be added in front here. We can have millimeter, milliliter, millisecond. Okay, even for this one, kilo here, we can have kilogram, we can have kilometer. So what's in front here is what determine the power of 10. Now it's not only these values that have these powers. It's not only power of 3 or power negative 3. So let's look at a table of these terms. So there are a lot of them. Now mostly they just end up to 18. So whatever value is at first here is what determines the power of that given value. For example, if we have, let's say, 2 kilogram. So since we have kilo here, it means we are going to go where there is kilo, which is of course here. So in this case, kilo has 10 power 3. So it means that whatever value we are going to multiply here for us to have this, it's going to be multiplied with 10 power 3. So make sure that you understand that point. So this table is very, very important. Make sure that you copy all of these because they're gonna be of help to you. So these are the abbreviations. Now the mostly important ones that you need to master starts from femto, that is 10 power negative 3, power negative 15 rather, and then also tera, which is 10 power negative, or rather positive 12. So within this, you have to master these. They are very, very important for you to know. So apart from understanding this concept now, let's look at some of the examples of how we can convert these same units into given different units. Let's look at the examples. So looking at the examples here, let's say you have, we have this. How can you convert these 10 kilometers to meters? How can we do that? So mind you, we have 10 kilometers. So to convert this into meters, we know the fact that since we have kilo here, kilo has the power 10, the power of 3 with 10. So base of 10 with power of 3. So this is what represents what? Kilo. So since it's meters, we are going to have meters here. So in this case, to convert 10 kilometers to meters, we are going to have 10 kilometers, okay, multiplied by, so since this kilo means 1000, okay, 1000, that is 10 power 3 is 1000, we are going to multiply this with 1000, okay. Or rather, if you don't want to do that, what we can do is by writing that the fact that 1 kilometer is the same as 10 power 3 what? Meters. We know that. So in this case, this kilometer and this kilometer will cancel out, and then we are just going to remain with what? 10 multiplied by 10 power 3 meters. Now, what is 10 multiplied by 10 power 3 meters? Of course, this is 100. Okay, this is 10,000 rather meters. So in this case then, it means that 1 or rather 10 kilometers is the same as 10,000 meters. So these are the same. So make sure that you understand this. Now, let's say if we had, how can you convert when you have been given different one? Let's say in this case we have, let's say we have 8 meters to centimeters. How can we convert this? So we know the fact that 1 meter is equivalent to 100 centimeters. So in this case then, we are going to have 8 meters multiplied by 1 meter, we know represents 100 or 10 power 2 centimeters. If you look at that table, this is there. So this meter and this meter will cancel each other, and then we are just simply going to have 8 multiplied by 10 power 2. So 10 power 2 multiplied by 8. So it's simply 8 multiplied by 10 power 2 centimeters. So of course this is going to give us what? 800 centimeters. So this is the answer. So make sure that you understand this, because whatever we are going to be doing here is going to be based on the same information that I'm from delivering. So let's look at other examples that would be of great help to us. Okay, hopefully that you understand this. So let's have some of the units. There are some of the units that we need to understand, because you can also convert different units from the SI unit to US customary units. So make sure that you understand these two. It's very, very important. So if we have, if we have 1 mile, this is the same as 1,600, 609 what? Meters. Okay, so 1 mile is equivalent to 1,609 meters, or this is also the same as 1.609 kilometers. So make sure that you understand this. So 1 mile is equivalent to 1,609 meters, which of course is also the same as 1.609 kilometers. Okay, so apart from this, let's look at other units that we need to be familiar with. The other units that we need to be familiar with let's say we have 1 feet is the same as, so make sure that you are writing this because they are very important. So 1 feet is the same as 0.304. Okay, let me just wrap this. It doesn't look like 0.06, rather 8. Okay, meters. So 1 feet is the same as 0.3048 meters, and in centimeters this is the same as 30.48 centimeters. So make sure that you understand these units. So the other one that we need to be familiar with are the inches. So what is 1 inch equal to the meters? So we have this table here. So this table is what's going to guide us into understanding whatever we have. So these are standard. Okay, you have to know them by heart. So you have to know that 1 mile is equivalent to these meters, is also equivalent to these kilometers. 1 feet is equivalent to these meters, is also equivalent to these centimeters. 1 meter is equivalent to 39.37 inches, and it's also equivalent to 3.281 feet. 1 inch is equivalent to 0.0254 meters, and it's also equivalent to 2.54 centimeters. So make sure that you know and understand these units by heart. So you can copy these in your notebook, and then you'll be referring to them whenever you have been asked to convert certain questions, such as example 2. So let's watch example 2. So example 2 asked us to convert 15.0 inches into centimeters. So how can we convert this? Now, if you look at the table that I am from showing, this one here, we know directly that 1 inch is the same as 2.54 centimeters. So let's use that fact. So in this case, for us to convert 15 inches into centimeters, we are going to have 15 inches multiplied by, we know that 1 inch is the same as 2.54 centimeters. So we are converting to centimeters. That's why I've used the centimeters on top there. So in this case, since we have the inches here and the inches there, we can cancel them, and then we just remain with 15 multiplied by 2.54 centimeters. So what could be the answer for this? So you have to use the calculator. 15 multiplied by 2.54 centimeters is the same as 38.1 centimeters. Okay, so this is the answer. Now let's answer question 3. So problem 3 says convert 152 miles per hour to meters per second. So 152 miles per hour. Okay, let me just write it here. Per hour into what? Meters per second. So firstly, let's discuss time. We know by fact that 1 hour represents 60 minutes, right? And we also know that 1 minute is the same as what? Is the same as 60 seconds. Okay, so since time has to be in seconds, it means that on this part here concerning time, we are done. So let's look at the distance now. The distance we have is mile, so we have to convert it into meters, since here it says meters per second. So we know by fact that 1 mile is the same as what? 1,690 meters, as discussed earlier. So we know that 1 mile is the same as 1,609 what? Meters. Okay, let me just write this properly. Okay, we have space there, so meters, like that. Now, having done this part here, what is the remaining part? The remaining part is the cancellation part. We know that this hour here will cancel with this hour here, this mile will cancel with this mile, this minute will cancel with these minutes. So this meter here does not have any other meter down here which we can cancel with, so it will just remain. Even this time, which is of course the second, does not have the second on top here, which we can cancel with. So in short, on top we are just going to remain with the unit, which is the meter, and down there we are going to remain with the unit, which is the second. So the values that we are remaining with as into figures is 152, which is this, multiplied with 1609 meters. So what is the answer if we multiply 152 multiplied by 1609 meters? So we are going to have this value here, okay, 68. On top, remember, there is a meter, which is of course here, divided by, here we have 60 and here we have 60, here we have 1. So 60 multiplied by 60 is 3600. 3600 multiplied by this one here, we are just going to have 3600. Of course, we have the second as the unit. Okay, so the second. Now, what is this value divided by 3600? What are we going to have? Okay, so we are going to have 67.9 meters per second. So these are the units in meters per second, and this is the value. So this is the answer for this particular question, which is problem number 3. Now let's go to problem number 4, because it's quite familiar. It's quite the same question. Of course, it's the same concept. It might be different, but it's just the same concept. So let's try to answer question 4 now in this case. Okay, so let me just wrap the top part here, since we don't need it anymore. We have used this concept. We have already used this, so we can simply get rid of it so that we can have some space. Okay, so in this case then, we have problem 4, which is saying if a car is traveling at a speed of 28 meters per second, is the driver exceeding the speed limit of 55 miles per hour? So this is the question. Now, how are we going to solve this question here? So first, to solve this question, to understand, or rather to give a feedback, we need to have the same units here so that we can know if the driver was exceeding the speed or not. So since the question has been given in meters per second, we can convert it in miles per hour. However, if you want, you can do the opposite. You can convert from miles per hour into meters per second. So let's convert the meters per second into miles per hour. We see how much we are going to have. So in this case then, we have 28 meters per second, and we know by fact that 1 mile gives what? Gives 1609 meters. So let's first convert into this unit. So we are just going to cancel this meter and this meter, of course. So in this case, we are just going to have, okay, we are going to have 28 multiplied by 1 mile. Of course, it's simply 28. Okay, so it's simply 28 mile over here, this is the second, right? So we have 1609 here seconds. So let's divide the two so that we can know what value we are going to have. So 28 divided by 1609. So we are going to have 1.74 multiplied by 10 power negative 2 miles per second. Okay, now if you look at this, it has an hour, so meaning the unit for time has to be in hours and not in seconds. So we have to convert this second into hour. So how can we do that? So let's write this, or let's just wrap this part here, since we have already used up this. So let's okay, we are going to do this. I hope that we are following, and make sure that you are writing somewhere so that you can understand whatever is going on here. So let's try to convert this second here into an hour so that we can have the mile per hour as well. So how can we do that? So we know that we have 1.74 multiplied by 10 power negative 2. Okay, we have mile per what? Per hour. Okay, sorry, per second. Now to understand this, we know that 1 hour, okay, by direct has 3600 seconds. Or if you don't want us to go direct, you can go step by step, okay, by just saying 1 minute. We know that 1 minute is equal to what? 60 seconds. And also we know that 1 hour, or rather let's write it down here, 1 hour is the same as 60 minutes. So if you have the unit down here and you want to cancel it, the other value has to be on top. If the value is on top, you want to cancel it, the other value has to be down there. So that's why I had done the opposite, because I already have the minute here. So if I had written down here, it couldn't have cancelled each other. So in this case, this second and this second cancels each other. This meter, or rather this minute and this minute, cancels each other. So I am remaining with what? An hour down there, and also this mile. So I have what I need. So all that's needed is the multiplication. So here I don't have any value down there since it's simply 1. So 1 multiplied by 1 is 1. 1 multiplied by 1 is simply 1. So down there we just have 1. So this value that we have to multiply with 60 and another 60 here. So we are remaining with this mile here, mind you. So in this case, this value multiplied by 60, we are going to have what? Okay, let's see, let's calculate. Okay, we are going to have 62.6 miles per hour. So this is the value in miles per hour. Now let's read the question again. They are saying, if a car is traveling at a speed of 28 meters per second, is the driver exceeding the speed limit of 55.0 miles per hour? Now, this 28 meters per second in miles per hour is 62.6 miles per hour. And of course, in this case, this person is exceeding because he is traveling at 62.6 miles per hour instead of 55.0 miles per hour. So the answer is that this driver is exceeding. Okay, so that's the answer for that question. Now let's look at the last example, which of course is the problem number 5. So make sure that you pause the video, you try out, you see if you have understood the concept. So let's look at this question. The question says, the traffic light turns green and the driver of a high performance car slams the accelerator to the floor. The accelerometer registers 22 meters per second squared. Then they say, convert this reading to kilometer per minute squared. How can we do that? Kilometer per minute squared. Now, mind you, we have 22. Okay, let me just wrap the top part here so that we are not inconvenienced. We have the whole space even on top there. We can use the top space also for us to write something there instead of just keeping the space. So in this case then, we have what? We have 22. Okay, 22 meters per second what? Squared. So we need to convert this firstly in kilometers and also time in minutes rather, squared. So in this case, we know the fact that 22, okay, there are a lot. Let me just do this. Okay, and then wrap now so that we have the space and we are not inconvenienced. So make sure that you are trying out also so that we move at the same pace, right? Okay. So in this case then, we have 22. We have been given 22. That is in meters per second squared. And we know we can write it in this form, meters squared. We know that in kilometer, 1 kilometer is the same as 1000 meters. Why? Because 1 kilo is equals to 10 power 3, and 10 power 3 of course is 1000. So I am done on this part. And the other part that we need to understand is that 1 meter, or rather 1 minute, rather, this is time. So we are dealing with time. 1 minute is equivalent to 60 what? Seconds. Now this time here is squared, so we are going to square this side here. Okay, we are going to square it. So in this case, this minute and, or rather this, okay, we have this second and this second will cancel each other, and also this meters and these meters will cancel each other. So what we are remaining with here now is that, sorry, this is not cancelled. Okay, I just made a mistake there, so let me just wrap. I just made a mistake, it wasn't supposed to be cancelled. Okay, so in this case we have the minute down there, we also have the kilometer up there. So in this case we are going to multiply this 22 with 60 what? Squared, and 60 squared is the same as 60 multiplied by 60. So 60 multiplied by 60 is 3600, multiplied by 22, that is in front there, we have 79,200 here. On top here we have what? Kilometer, right? Okay, then down there we have 1000 here. So 1000 over 1000, and this minute is what? Squared, so it's minute squared. So in this case, let's divide by 1000 what we have on top there. So we are going to have what? We are going to have 79.2 kilometer. Okay, kilometer per. Since it's minute, you just have to write mean. Okay, squared. You don't have to write just m like I wrote here, because it will mean meters. So in this case it's 79.2 kilometers per minute squared. So this is the answer to the question, which is problem 5 in this case. So this is how we basically convert the units. So make sure that you go through again this topic, conversion units, and then you will understand much what we have done here. So hopefully that you have learned something at the end of today, and of course don't forget to like and subscribe to our channel so that you can learn a lot more as you have learned today. Stay blessed.